Well, welcome everybody. It looks like we've got quite a few attendees this morning, which is great. We are today going to be hosting our next event in our EPC Engage series. Just so everybody's aware, we've been doing this type of format now for, 9 months or so. A lot of different subjects that are out on our website that I would encourage all of you to view those different links. We talk about various subjects in each of the presentations that we've done so far. But today we are going to be talking about the do's and don'ts of concrete work. So if we can move to the next slide, Nina. I just also want to highlight that all of these sessions are recorded. So all the past ones you can go back and rewatch. This one today will be recorded and available on our Planning and Community Development website. So that's the county's Planning and Community Development Department website. There's a tab on the left that will take you to EPC Engage. So anybody that maybe couldn't attend today that you think would benefit from this, I would highly recommend that you let them know that they can watch that after the fact. Before we get started with our event today, I did want to highlight that we have 2 additional events coming up. One in November and another in January. The one in November will be a presentation really geared towards realtors, but I think probably appraisers as well would benefit from that one. And just anybody who's generally curious about planning and zoning. We're calling it a realtor's guide to planning and zoning, and obviously we'll be throwing in some subdivision type topics as well, help people understand that process, in addition to the zoning requirements that the county has and how to navigate all of that. And then in January, we're going to be looking at the topic of financial assurances. So this is collateral that's put up in support of a development to secure performance of that development, but also securing construction of public improvements as well as stormwater improvements, both temporary and ongoing. So really excited about both of those coming up. Hopefully all of you can attend those as well. Next slide, Nina. So today we have really an all-star group of folks that have joined with the county to present all this information to you. Just really exciting group. We have folks from Colorado Ready Mix Concrete Association, Action Ready Mix, Pete Lean & Sons, Martin Marietta, Transit Mix, and then our partners at the City of Colorado Springs. So if there's a question out there about concrete, I can't imagine that there isn't somebody on this presentation that wouldn't be able to answer that. And in the kind of the context of questions, you'll notice that at the bottom of your screen is a box that's titled Meeting Chat. If you want to drop your questions into that box as we go through the presentation, we will be taking those questions at the conclusion of the presentation, and hopefully we'll be able to answer all of those as they come up. Next slide, Nina. So as I mentioned, we have a all-star group here. I'm not one of those all-stars. That is not my specialty. I am Craig Dossie. I'm the Executive Director of the Planning and Community Development Department for El Paso County. But today we have Jason LaRue, Matt McCombs, Joe Griego, Don Barone, Matt Schaefer, and Tyra Sandy, who actually is going to kick us off. But we really want to thank all these folks for taking the time to provide this information, answer any questions. This is a complicated subject, and I think we have all the right people here to touch on those various items. So if Tyra, if you're ready, we will hand it off to you.
Awesome, thanks, Craig. So today we're just going to talk about basic concrete inspection. We're going to go over concrete specifications, concrete delivery, physical property testing, concrete cylinders, casting and curing, and some additional information y'all should have when out on a job site. So first we're going to start with concrete specifications. Next slide. All right, so just a little highlight. El Paso County follows CDOT, which is more of a performance-based mix where the mix can be done however, it just has to have the desired results. where the City of Colorado Springs follows more prescriptive style concrete, which means we put in together how we want the mix to go together and accept the results as they are done. Next slide. So if you're doing work in El Paso County utilizes CDOT's approved mix designs list, which can be found on CDOT's webpage. Predominantly, you would use a class DEP, which would be for paving, structures, curb and gutter, etc. And then there's a BZ mix that you would be using for like drilled piers. Next. All right. The City of Colorado Springs, for almost everything you do, you would be utilizing our approved mix designs, which are available on our website. In general, it's just called the City Mix. So that is available on the website if you guys need it. Next. So fast. Common problems and solutions. So oftentimes we have problems with contractors or suppliers assuming that the mix can be used for whichever job site. Often confusing city and county. That kind of comes into play when we're close to the borders. What mix to use, and sometimes contractors or suppliers provide the incorrect mix for the job. So it's really important to make sure you know what the pre-approved mixes are for your project, verify what is being delivered, and take a moment and set up with the contractor and the supplier to make sure what mixes should be delivered to the job site. And with that, I think it goes to Jason for concrete delivery.
Thanks, Tara. Good morning, everybody. So the next few slides, we're really just going to be showing examples of each supplier's batch tickets, batch weights, delivery tickets. Start off with ours here, just a general format of our delivery ticket where you've got your contractor address where it's being delivered up in top left, all of our plant information up in the top left address, and then you get down into what you really need to know, middle of the page here, where you're going to have quantity in the truck, quantity ordered for the total job, and then your mix designation and description. Top right, you have the time at which the ticket was printed, which can differ from the actual time that the load is actually batched when the water's introduced with the cement. And next slide, we'll go to the batch weights. So when looking at time for batch, the time you really want to go off of is batch weights, which you'll see in the top right corner there. But this also gives you your constituents, the mix design, design quantities required for that particular load, and then what was actually batched. We only provide these as Action Ready Mix only provides these upon request. So for more information, sorry here, you've got your moisture percentages, which gives you your actual water content based on your moistures in your aggregates, which you can use to calculate your water cement ratio and amount of water allowable to add to meet your maximum water cement ratio based on your specs, which I believe Mac will be going more into depth with here in a few slides. But that's just the basic general layout of our tickets there. So I believe it goes next to Pete Lean.
Yes, good morning. This is Joe Grego. I just wanted to address basics, again, similar to Jason. If you look at the left side of the screen, the batch ticket information highlighted in yellow, starting from the top, working away to the left and all the way down. You have your ticket information, your batch time, the date that the load was requested, the slump it was requested at, the truck number, and below that, the amount of yards in quantity per load, the brief description of the mix design, and to the right of that, the product code 40C351, that is the actual mix design that is going to be placed for that day. And over on the right side of the screen, that's our batch weights, which are on the back of the ticket. And again, the top line summarizes the truck number, the time it was batched, the date it was delivered. The second line is the amount of yards being delivered, and then the mix code to the right of that. And the key important numbers is in the fourth column, highlighted in yellow, that is the cementitious material, and they will use that along with the actual number at the bottom where it says actual, and it's highlighted in yellow, 149.6 gallons. And they can use that to verify the water cement ratio, which is located to the left of that on our ticket, which we place for everyone's, to make it easier to use. And with that, I think I will go to the next slide and turn over to Mac, I believe, or I'm sorry, Don.
Thanks, Joe. So what you're looking at here is a pretty standard Martin Marietta batch ticket. One thing to note is that batch weights are not automatically printed on the tickets and are typically printed upon request. In the event that you may have forgotten or down the road you want to see them, you can always request them from your sales representative or the dispatch. So going over the ticket, starting at the top, it's not highlighted, but it is important that you verify that you are the correct customer, of course, this one being RME. As we move down the ticket, you see your mix code, in this case being ZA4115SP, and then a brief description, 4,500 PSI exterior. As we go further down the ticket, you see that it's a 10 cubic yard load of concrete. This customer has ordered 110 yards, and we've at this time delivered 100 cubic yards. And the slump at the tail end of the left side here says that what was ordered is a 6.5 inch slump. As you look at the batch weights on the right, you're going to see a list of all the components in the ticket, or in the truck rather. And the key thing to take away here is the highlighted portion saying water to add, in this case being 12.1 gallons. This is the water that you're able to add to the truck and still be within the design water to cement ratio. And if you dig into the ticket a little bit more, you'll see the variance column. Those are determined by C94. We have a pretty tight window on what we actually can put in the truck and the tolerances there being. Further right, you'll see the actual water cement ratio at the top being a 0.433. With that, we will proceed. Thank you.
Nina, who's our next speaker?
Sorry about that. I was still up.
Sorry, I was muted and couldn't unmute myself here until I got out of presentation mode. The next speaker is Matt.
Yes, sorry, Nina, I was also muted still. I'm Mac Schaefer with Transit Mix. This, if you back up one slide, this is part of our paperless delivery system and batching tickets. This shows what time the load was started to be batched, what time the truck leaves the yard, what time it shows up. You can get that through our Concrete Direct app. Now, if you want to drop to the next slide, please. This is what one of our paper batch tickets look like. These will come only on request. We do have, through the paperless delivery, batch tickets available. And if you don't have access to our Concrete Direct app, there's a QR code on all of our trucks that you can take a picture of, and that will also give you the batch ticket. Again, the important things are who your customer is, what mix we're looking at, load size, those type of things. We talk, and I'll talk a little bit more in the next slide about water cement ratio. And if you'll take a look under the section where you're looking at some percentages, one is 3.76%, the other has a negative number, and it shows negative water going into the mix. That goes into the calculation, and we see some aggregates that have what's known as free water, which is additional water that comes in above what is saturated but surface dry in the design process. So The material that has 11 gallons of water being removed means that that's in an absorptive state. It's going to actually take water out of the mix. That water is not calculated in the water cement ratio because it does not affect the water cement ratio because it's internal to that aggregate. Next slide, please. Run through some quick numbers, and I'm using the numbers that were in that previous batch ticket. If we had cement at 4,540 pounds and fly ash of 1,120 pounds, our total cementitious would be 5,660 pounds. Going back to that previous batch ticket, we had 299 gallons of water, which is 2,491 pounds. We had free water, and if you remember, we had 70 gallons of water that was associated with our wet sand, and we took 11 gallons of water out that was associated with our absorptive aggregate. That left us 483 pounds of what's known as free water. That total water content in this mix would be 2,974 pounds. When we look at our total cementitious content, and just to differentiate, the top slide says water cement ratio. When we start adding natural pozzolans or silica fume or fly ash, those type of components, you go from a water cement ratio to a water cementitious ratio. So our total water cementitious ratio would be our 2,974 pounds of water divided by that total cementitious of 5,660 pounds, leaves us a water cement ratio of 0.53. Next slide, please.
So now
Jason LaRue is going to take over from here.
Thanks, Mac. Okay, so here we're going to be going over just concrete delivery, excuse me, in general. Dealing with some of the components on the truck that need to be paid attention to once the concrete's delivered, if there's to be addition of water, once the truck hits the site, the load hits the site, and you need to adjust slump, and any other, the revolution counts, you want to pay attention to those, and any other truck concerns that you may want to keep your eyes out for when the truck shows up on site. Next slide. So here you've got a revolution counter. I know in some trucks, they're not all digital. Some of them are analog, old rotation style. But here is an example of one of our drum counters in one of our trucks. And it for every one revolution, it'll count up. Upon delivery, you want to see about 70 to 100 revolutions. You want to look at that to be ensured that the load wasn't beat up on the way to the job and heat up, so that way it doesn't start hydrating too fast on you. Anytime that there's an addition of admixture or water, there should be a minimum of 30 revolutions on that mix after that addition to make sure that the homogeneous mixture is attained and the air in the water is allowed to mix completely through the entire load. You don't want to add water and put 10 revs on it, because then you'll see that the top end of that load will be wetter than the tail end of that load. And then as far as end of placement, you don't want to exceed 300 revolutions. That's based off of ASTM and ACI standards. Next slide, please. Here's an example of a water meter we have on our truck through a system we have on our trucks called Trimble. It's a tracking system. I know not all trucks have these meters. Some of them just have the sight glasses on the side of the water tank. But you want to ensure that one of those meters or gauges is working when you're adding water, to make sure that you're putting in the appropriate amount of water and not putting in too much to break your water cementitious rate. Next slide. And then one big thing with delivery, I mean, as far as mixing, I know with our plant, we run dry batch plants, and this is extremely important for us but still important for even central batch plants, is the cleanliness of the drum on the inside, the buildup on the fins. Those fins are meant to mix that concrete and get it uniform and homogeneous and make sure that everything is mixed properly and you don't have any segregation. If you've got a bunch of buildup on those fins, you're going to have several problems from, again, a uniform mixture when mixing. Discharge can be difficult. And then you can also get, a lot of the times we'll see big cement balls, and that just goes back to the mixing. So you want to make sure that the truck that you have on site, if you're adding water or anything and you're mixing it up, if something looks weird, take a look at those fins or have the driver take a look at those fins and make sure they're clean. Another thing to look out for is product valves that shoots the water into the loads for additional water. If sometimes they'll have a lot of buildup on them and it'll take forever to add water that way, or they'll be leaking. And if they're leaking, it could leak water the entire time through the pour or in transit to the job, and that could cause loads to show up too wet. Next slide. And then some common problems that we see once the truck and load gets on site. No batch weights provided if requested, especially on spec work like city work or CDOT work. If no batch weights are provided, your only option is really to reject the load if the weights can't be supplied in a timely manner. If there's time left, I mean, we've run into some situations where we forget to send the batch weights. Some inspectors will take pictures sent to them of the batch weights, others won't. That's completely up to the inspector on site. Sending the wrong mix. Once you verify what mix has been sent to you based off the delivery ticket or the batch weights, wrong mix, wrong application, reject that load. Over the time limit, same deal. There's really not much you can do about that. There's a time limit set of 90 minutes. And if you break that 90-minute barrier, then reject load as well. Same with over water cement ratio. Once you've broken that water cement ratio, there's concerns of strength, cracking, increased permeability. So you'll go ahead and reject the load as well. Now, when it comes to low slump, high slump, or high air, low air, adjustments should be allowed on site. Say you've got a low air, you need to add air. There should be a one-time adjustment for a retest. If you still don't meet, then reject the load. And high slump and high air, same deal. I know as a QC person, we have plenty of tricks we can use to try to get that load to come back down where we need to, as long as there's enough available time and you're not breaking that 90-minute time limit. And I think now I turn it over to Don.
Matt.
No, I believe it goes.
I'm sorry, to Matt.
Thanks, Jason. We're going to talk a little bit about the physical properties and the testing of concrete now, and I'm going to start with sampling concrete. Next slide, please. Proper sampling is governed by ASTM C-172. Next slide, please. Some of the important things about sampling, and probably the most important thing about sampling, is if a proper sample isn't collected, and actually we have a representative sample of what's being delivered, every other test beyond that becomes invalid. So if we've done things that don't represent the true mix, your air is probably suspect, your slump is suspect, every other test afterwards becomes suspect. So that being said, how do we get the most representative sample? Because ultimately, every producer in this meeting today wants one thing, and that's an accurate representation and an accurate reporting of what we're delivering to a job site. So the first rule is all admixtures and all water must be in the load before a sample is taken for acceptance. if there's a high range to be added, if there's a slump adjustment that needs to be done, those need to be done before that sample's taken. And 30 revs must be put on that. That 30 revolutions is not only a CDOT requirement, which would handle the county requirements, it's also an ASTM C94 requirement that after that addition. So those 30 revolutions have to be put on the truck. Make sure that you're getting a homogeneous mix. We're going to test from the middle third of the load, and we should be looking for 2 collections. And if you're testing, in most cases, in our market, you're going to be testing from a revolving drum truck discharge. And what you're looking to do is capture the entire stream. If it's discharging down the chute, you would have to pass your receptacle, whether that be a bucket. If you're going to use a wheelbarrow, you can divert the entire flow of the chute into your wheelbarrow. But you must, if you're not going to use a wheelbarrow, you must have that 5-gallon bucket or one of the another collector pass through the entire stream. You can't use a shovel to stop the flow. You can only use the drum to regulate, and the rotation of the drum to regulate the discharge of that mix. The other thing that's really important, you have to have a cubic foot of material. And to keep in mind, that's going to be somewhere in the neighborhood of 140 to 150 pounds. So really important that you're not just, if you just get one bucket, you don't have enough, there's no way in a 5-gallon bucket to get enough material to run all the tests that you're looking at performing. The other type of sampling that you might see for city or county would be if there was mainline paving being done that was at a very low slump and you were going to have a paving machine and they were to discharge concrete onto the ground in front of that paver. If you're sampling at that point, you'll collect 5 samples. If you have a truck that discharges, you're going to want to get at least 5 samples from the ground, making sure that you don't collect anything, any soils or any sub-base or base material in that as well. The other really important thing is, especially in the hot, dry weather and the wind that we get here in Colorado Springs, you need to protect your sample from sun, wind, rapid evaporation, and any type of contamination. Really critical. The other thing, and it goes back a little bit to our water cement ratio, we're allowed as producers, if there is a low air content or a low slump that shows up, by ASTM C94, we're allowed as producers and contractors to make those adjustments. Jason talked a little bit about that. And a lot of times there's a misconception that we get there, we may be low on air, you may be low on slump. And we'll see an inspector say, well, you're not allowed to add water to this, or you're not allowed to make an air adjustment. That's inaccurate. By ASTM C94, which the city is governed by, and they're the ones that write the spec, we're allowed to make those adjustments. As long as we do not exceed the water cement ratio. Excuse me. As long as we don't exceed the water cement ratio. Next slide, please. Next time we're going to talk about is temperature. Seems like a pretty straightforward subject. One thing that we are seeing more and more of is folks with the laser guns or that type of piece of equipment for measuring temperatures. Those are not acceptable for accurate readings as far as concrete. To get an accurate reading, you have to have at least 3 inches of concrete around your around the probe on your on your thermometer. You'll want to, and that's on the bottom and all sides. So the easiest way to do that, if you've got a receptacle, kind of mound your concrete up so that you've got 3 inches on the bottom, 3 inches on all sides. Poke your thermometer down in, and then you want to kind of compress the concrete back around that probe so you don't have any air around it. We want to make sure that that thermometer is in there a minimum of 2 minutes, not more than 5 minutes, and that you take your reading and record it while the thermometer is still in the concrete. Don't pull the thermometer out and then take your reading. You need to take your reading while your concrete or your thermometer's in the concrete. And we report to the closest 1 degree Fahrenheit. Now I believe Joe Grego is going to take over the remaining physical properties.
Okay, thank you, Mac. I think this slide is a video. Am I correct, Nina?
Yep.
And we're going to watch it so we can see how the presentation, the actual test is supposed to take place. Here they are taking their thermometer, and I apologize, I thought there was audio to this. Should have it embedded at a minimum of 3 inches in. I think we're
I'm
reading.
just going back in. It looks like our setting got undone, so I am going to unshare my screen and reshare. That way we have the audio.
Okay. Thank you. My apologies to everyone. We do have technical difficulties in this day and age still.
Place your thermometer into the sample, making sure there's 3 inches all the way around, including below the probe sensor. Know where the sensor is on your thermometer, as some are at the center of the probe, as shown here by this dimple on the one that I have. Once in the concrete, gently press around the thermometer to close any voids and keep ambient air from influencing the temperature. Leave the thermometer in for 2 to 5 minutes. Once you are ready to read the temperature, just read it. Don't take it out, don't twist it, just don't mess with it. After you read the thermometer, remove it and report to the nearest 1 degree Fahrenheit.
Okay, next slide, Nina. This is just a picture of a young man performing a concrete test. One of the key things we want to address here while we're talking about the physical property testing, he's getting ready to do an air content and unit weight test. The same sample of material can be used for the unit weight test and the air content test. The key things we need to address, though, are the fact that the pot has to be filled up in equal lifts, 3 equal lifts. Each lift should be rotted 25 times. Each time they add concrete to the previous lift, or to the the previous lift, they should penetrate that concrete approximately 1 inch. They should consolidate each lift, tapping it with a mallet 10 to 15 times. In the event you have concrete that is 1.5 inches or less, sometimes you may have to tap it more than that to get the voids to close. They should fill the concrete level to just over 1/8 of an inch above the top of the rim of the air pot. The reason they specify 1/8 of an inch is because if you overfill it more than that, you can influence the unit weight by adding more aggregate and cementitious material, and those tend to be heavier, and it can affect your weight by up to 2 or 3 pounds. If you fill it to that 1/8 inch over, you remove the concrete with a strike-off plate, following the proper ASTM procedures. you make it flat. And we'll show you that in the next couple of slides what we mean by that. You clean the rim to create a watertight seal, you weigh the sample, and then you perform the air test. If we can go to the next slide, Nina. And here's a video of the procedures I just talked about.
Pot. Then weigh your pot. The scale should be set on a flat, level, firm surface. Place the pot on a level, flat, firm surface and fill in 3 equal volumes. Fill the first lift about 1/3 of the volume. Rod the first lift 25 times, uniformly across the surface section. Tap the sides 10 to 15 times with a mallet to release the air pockets and close the tamping rod voids. The second lift gets filled to 2/3 of the volume. Rod again 25 times across the surface cross section, penetrating into the first layer about 1 inch without stirring. Then tap all the sides of the pot a total of 10 to 15 times smartly. Fill the third and final layer the last 1/3 of the volume. Avoid overfilling. Rod the final lift 25 times, again across the surface area and penetrating the previous second layer only 1 inch without stirring again. Tap all the sides of the pot 10 to 15 times smartly, again to close the voids. A representative amount of material can be added or removed at this time to reach the optimal level. Additional rodding or tapping should not be performed after adding or removing the material. Using the strike-off plate, the top surface should be finished smoothly. Press the plate flat onto the pot to cover 2/3 of the top surface. In a zigzag pattern, pull the plate towards you until the entire plate is off the pot, keeping the plate flat the entire time. Then place the plate to the original spot covering 2/3 of the top surface, and again in a zigzag pattern, push the plate away from you until the entire plate crosses the surface, keeping it flat again. Then incline the plate and strike off the surface from one end to another several times. Finally, make sure to clean off the exterior of the pot entirely, along the edge of the rim, around the handles if they're there, and the sides and along the bottom edge of the pot. Once clean, weigh the pot full and calculate the density to the nearest 0.1 pounds per cubic foot.
Okay, next slide. Some of the problems that we see during the unit weight test and the air test is the air meter is dirty and not well maintained. Again, that can be alleviated by wiping down the air meter every time. And if not, it's the inspector's job to request that they clean and maintain the air meter properly. If it's not working properly, you're going to have leaks, you're going to have improper readings. In other words, you're going to have air or water leaking out the side as they perform the test, or you're going to get unusually low or unusually high readings. We've seen those in the field as well. This can also be a result of the air meter not being calibrated. You're going to have that because a lot of times you got people driving around with their air meters in the back of the truck. It's jostling around because, well, traffic is crazy in this town sometimes, and so the air meter could slide back and forth, you know, and just that continually jostling and banging can affect the calibration of your air meter. And although ASTM doesn't really give you a specific time or when you should calibrate it, except to say that it's as needed. So as needed could vary. If that air meter gets banged up from one day to the next, they can need to calibrate that air meter every week. It could be every couple days. But at a minimum, the testing lab should take care to calibrate their air meter at least once a month. As ready mix producers, because we have so much writing on the results that we see, if our air meters are not calibrated, we are taking a big risk. So we tend to calibrate ours every week at a minimum. All we ask is that the same courtesy is done for us. Now, the other thing we see is when we are doing comparison testing between the quality assurance, which is usually the representative of the city, versus quality control, which is usually the ready mix producer or their representative. If there is more than a 0.5% variation between the two tests, CDOT requires that the air meters should be calibrated. And one of the simple ways to see who is possibly out of calibration is to use what is called an air bomb or an air void. They're 5% in volume, and when placed inside the pot, we're not doing this for calibration. I must stress that. We are not calibrating the air pot with that. That's a completely different procedure. But what we're doing is we're checking to see how much air volume is displaced versus how much is being read by the air meter. If the calibration of the air pot is accurate, the air meter reading should be 5%, plus or minus 1/10 of 1%. And anybody who is confident in their equipment and their results should not have any problems doing this. So that's one quick way to check to see whose air meter is reading correctly. Next slide, Nina. Okay, on this picture on the left-hand side, if you can tell, the air pot, it's not exactly level. On the left side of the air pot, you can see a little bit of the concrete has settled below the rim, and on the right side of the air pot, it's settled slightly above the rim, and also you can tell the finish is not very good as well. Whereas on the right-hand picture, you can tell the air pot the concrete is distributed evenly, and there doesn't appear to be any settling or high spots of the concrete on that air pot. And that's what we mean by having the test done properly on a flat level surface. Next slide, Nate. I believe this is a video as well.
To determine the density of the concrete, you must have the empty pot weight, the full pot weight, and the volume of the pot. The volume of the pot is determined through calibration, which we won't go over in this video, which should be recorded to the nearest thousandth. Subtract the empty pot weight from the full pot weight to determine the weight of the concrete. Then divide by the volume of the pot. This results in the density of the concrete, which for a standard concrete should be between 135 and 160 pounds per cubic foot. Using the batch ticket, the theoretical density can also be determined. Yield is also something that is helpful on site. It is defined as the volume of the concrete produced based on the combined known materials that makes it up. The purchaser of the concrete will look for yield to assist in knowing if they are getting the amount of concrete they have ordered. Yield is calculated using the weights of all of the materials batched, divided by the density, then multiplied by 27, resulting in cubic yards. Relative yield is the ratio of the actual concrete volume divided by the designed batch volume, or yield divided by design yield. Cement content can be determined based on the batch cement weights divided by the actual volume, or yield. Gravimetric air content can be calculated either theoretically or using the actual concrete batched.
Okay, next slide, please. This picture is just one that we wanted to show you. It's a good picture of the actual air meters that are used in the field for most of the tests that we see performed on a daily basis. One thing you'll notice is it's probably one of the cleanest air meters that we've ever seen in use. But then again, it's CDOT, so we here in Colorado Springs tend to do more work out in the field, so our equipment tends to get a little dirtier. Next slide, please. I think this is a video as well.
Make sure to clean off the exterior of the pot entirely, along the edge of the rim, around the handles if they're there, and the sides and along the bottom edge of the pot. Clean off the rim and the flange of the pot, as well as dampen and clean the cover assembly. Do this even if unit weight was performed to make sure the lip of the pot is clean. Clamp the cover assembly to the pot, making sure you get a tight seal. Make sure the main air valve is closed. In this case, it is a push-pull lever. The petcock should be open. Then inject water into one of the petcocks, slightly jarring or tipping the pot towards the injection side while filling. This will force the air bubbles out of the opposite petcock. Do not inject water into one petcock, then into the other. Stay on one petcock, otherwise you will continue introducing air and chasing it out by going back and forth. Check to make sure the bleeder valve is closed, then begin pumping air into the upper chamber until the gauge is at the correct initial pressure. The petcocks need to stay open during this process, as air will exit from them while pumping if there's a leak at the cover assembly closing pin. Once near the initial pressure, tap the back of the gauge a few times while letting the compressed air to cool and equalize. Adjust and stabilize the gauge hand at the initial pressure by slightly bleeding or pumping while tapping the back of the gauge. Now close the petcocks. Open and hold the main air valve or the top lever, then immediately tap the sides of the pot smartly. Lightly tap the back of the gauge to stabilize the needle. While still holding the main air valve down, read the air pressure on the dial to the nearest 0.1%. Then release the main air valve and release the pressure by opening the petcocks. Remove the cover, then release the pressure in the upper chamber using the main air release valve or the bleeder valve.
Okay, this picture is again just to show you that the reading of the air meter once it's done. Next slide. Okay, now we're going to talk about the slump. When you're filling the mold, the one thing that we should always remember is that before you do your slump, it should be placed on a flat level ground. The equipment should be moistened. So with the sponge, they should moisten so that there's no free water on the rod, the slump cone, and the slump plate. The excess water introduced if you have free water on the slump plate or the cone can affect the slump. The next thing is when they place the slump cone on the plate, they should do it in 3 equal volume lifts. Each lift should be rodded 25 times. And then at the top of the slump cone, they should use a screeding motion of the concrete as they're rolling the rod. So again, screeding plus rolling, that is a valid way to do it. If they're just swiping the rod side to side, that is the improper technique, and that is not accepted by ASTM. Once they're done rodding and treating and topping off the slump cone, they should remove all the excess concrete from around the edge of the slump cone, holding it down tight, making sure that the cone is not moving. The reason they're removing the excess concrete from the side is because we do not want the concrete inside the slump cone to be restricted once the cone is lifted off. The cone, when they start the procedure, should be lifted at a rate of 5 seconds plus or minus 2. Now, the thing is, everyone takes that to mean that, oh, I can pull the slump cone in 3 seconds, or I can take 7 seconds to pull it. Yes, that is because that's how the code is written. You're allowed 5 seconds plus or minus 2 seconds. But in discussions at the ASTM meetings, it has been pointed out that the plus or minus 2 seconds is to account for a person's inability to count to 5 properly. So again, it should be 5 seconds. The plus or minus 2 seconds is only to account for somebody's lack of ability to count to 5 in the proper time period. Once they do remove the mold and they measure the slump, they should remove the mold without twisting the mold, as that can affect the concrete because it can grab it and suck it up slightly and cause it to fall artificially fast once that's done. Another thing we notice is that by twisting, it can also cause the concrete to lean to one side too much, and that is improper as well. Now you'll notice the table right below the picture, and that table addresses the in-operator precision. And what that means is the same person doing a slump on the same material can have an effect on concrete that can be anywhere from a 1/4 inch to almost a 1/2 inch, depending on how wet the concrete is. So depending on how that person performs the test every time, he could or she could have a variation between each test. Next slide. I think this is a video that'll summarize the whole test.
Flat, non-absorbent surface, free of vibration. Dampen your mold and base plate. There should not be any dripping or excess water on this equipment, which would cause a higher slump than actual. Hold the mold firmly in place by standing on the ears of the cone with the balls of your feet, making sure you don't rock the cone during filling. Using a base plate with clamps is also acceptable. Using the scoop, fill the mold in 3 layers. For the first layer, to 1/3 of the volume, about 2 5/8 inch up from the bottom of the cone. Rod the layer 25 times through the full depth of the layer, inclining the rod slightly, starting from the outside and progressing to the middle with vertical strokes. The second layer then should be filled to about 2/3 of the volume, which is about 6 1/8 inches from the bottom. Rod again 25 times through the full layer to about 1 inch into the first layer, again distributing the strokes across the entire area. On the third and final layer, keep the concrete to above the top opening of the cone. Rod the full depth of the layer 25 times, including about 1 inch into the second layer, distributing the strokes across the surface area. During rodding of this final layer, make sure to keep the concrete heaping above the rim of the cone. If you have to stop to refill the cone, continue the count of the rodding from where you stopped. If you need to refill multiple times, do so to keep the concrete heaping over the rim. After finishing the third layer, use the rod to strike off the surface of the cone by screeding and rotating the rod across the surface, while still keeping pressure on the cone. Remove any excess concrete from the base of the mold. This does not mean grabbing the sponge and cleaning the concrete. Lift the mold in a steady vertical motion. The cone should be lifted straight up 12 inches in 5 seconds, plus or minus 2 seconds. Immediately measure the slump. This is the distance between the top of the mold to the original displaced center of the top surface of the concrete. If the center of the top surface is lower than the edge of that circle, you do not take an average measurement, but still measure from the center of the surface. The slump test should be complete in no more than 2.5 minutes, starting when the first scoop goes in until the end of the 12-inch lift of the cone. Report the slump to the nearest 1/4 inch.
Okay. Now, other common problems that we see out on the job site. Low air, high air. Those can all be a result of the concrete just not having enough air, having too high air, or the equipment not being in calibration. And a good way is to have quality assurance and quality control out on the job site. The purpose of having the inspector out on site, the testing lab, I should say, not the inspector, is so that they test for the city of Colorado Springs. They're not testing for the ready-mix suppliers. And so the ready-mix suppliers should have their own representative out on site when they are doing their test, and if so, side by side with the quality assurance. When they do the unit weight and air content, tests are not correlating. Oftentimes, if you have a low unit weight of, like, for example, 33 pounds, but the air content is reading 5%, that's usually what we mean by not correlating, because we're used to seeing a air unit weight of roughly around 34.5 when that happens. Anytime we see it drop below 34 pounds, depending on the air meter being used and the weight of that air meter, a reading of 33 pounds would indicate a high air content. So if we have a 5% air and a 33-pound unit weight, they're not correlating. So something's going on there. It can either be the scale's off or the air content reading of the air meter is off, and vice versa. We could have a heavy unit weight and a high air reading. So again, not correlating. High slump. Well, we all know that the slump can be a problem. Can we go to the next slide, Nina? I think we have. There we go. Whoa, go back one. There we go. We can have low slump or high slump. City of Colorado Springs has a maximum slump of 4 inches for their projects for 2C and PPRTA. With that being said, they have a minimum requirement, because they follow ASTM procedures, of 2.5 inches. So if that concrete shows up and it's not a 2.5-inch slump, chances are your air content and your workability of your mix are going to be a little low. We strongly urge everyone to make sure that that slump is at least a 2.5-inch slump before they perform their test. So getting back to what Matt and Jason were talking about, we can add water to help increase that slump to where it is above the 2.5-inch mark. So somewhere between that 2.5-inch and 4 inches is a sweet spot, and that should have a positive correlation with our air content as well. And again, we're talking high slump as well. So sometimes we see that high slump. The only solution we have to that is if it's exceeded the water demand, the water cement ratio, then you have to reject the truck. Otherwise, the truck can sit there and hoping that the hydration takes place, dries up, as what we would also call it in layman's terms, to get it within that 4-inch slump maximum requirement. So solutions to those problems that I addressed on the left are equipment calibration. As Jason and Mac both said, we can add air to the concrete. There are also products that we can use to remove some of the air. Verification testing with quality control versus the quality assurance to verify that everybody's doing their equipment's reading correctly. And if everything else is where the slump can't be corrected, air can't be corrected, the only solution is to reject the truck and replace it. Next slide.
So now Dawn is going to present the next section, and Dawn and all of the future presenters, keep in mind that we have half an hour left in our scheduled time. We want to leave some time for questions.
Sure, thank you, Nina. So we're going to get into ASTM C31 for the casting, curing, and transporting cylinders, and also C39 for actually testing the compressive strength. Here, JT with the CRMCA has prepared a video for us.
Rod the full depth of the lift without damaging the bottom of the cylinder mold. This means you will tap the bottom, but not strike it hard. Then tap the sides of the mold lightly 10 to 15 times with a mallet to close the rotting holes and release the trapped air pockets. Repeat the process by filling concrete to the top of the mold. Rod the layer 25 times uniformly again, penetrating about 1 inch into the first layer. Tap the sides of the mold 10 to 15 times with a mallet. Strike off the surface of the mold using a tamping rod when consistency allows for it. A handheld float or trowel can be used alternatively to smooth the surface. Provide protection to prevent moisture loss, using the provided lid or other material if not available. After finishing the cylinder, mark the specimen to identify the concrete it represents, i.e. the date, the project, the ticket number, etc. It's more practical to mark the mold before beginning the filling process, and this is fine. Then move the specimen to the initial curing location. Ideally, testing and casting should occur as close to the initial curing location on site.
Okay, so you're hearing, all of these rod 25 times, and that's what's great about ASTM is that it's created a standardized procedure for everyone to follow these tests. One thing that is difficult with ASTM though is that it tends to turn into a jump around different specs to find the whole picture, and C31 is no exception. Looking into the initial cure state, you have two methods here. You have standard curing and you have field curing, both done in the field despite the name. So standard curing is what you're going to use for acceptance to prove that the mix meets the specified strength that the supplier is required to supply. And when you are standard curing, you're required to keep those cylinders level within 1/4 inch per foot. You're required to keep them in a temperature controlled area, typically water. You'll see all the way left, it's insulated box, and all the way far right, you'll see that those cylinders aren't protected at all. The curing requirements depend on the PSI value. If they're 6,000 PSI, under 6,000 PSI, you have between 60 and 80 degrees Fahrenheit. And if they're over 6,000 PSI, tightens up a little bit to 68 to 78 degrees Fahrenheit. C31 leaves it kind of open as to how you do this, but what is required is that you have a minimum maximum thermometer shown in the middle picture, and you report that on your final cylinder report sheet. What C31 fails to do is covered in C94, where C94 actually requires you to immerse the cylinders in water immediately after finishing and keep that water in the temperature requirements stated in C31. As you could imagine, this is a difficult task when in the field. A lot of times we don't have access to power 24 hours a day, for instance. You might not have a level area on a job site. It might be hard to find somewhere that's free from vehicular traffic. And the biggest one that we commonly see is that all projects aren't gated, and the public has access to these. Other tradesmen have access to these test cylinders, and they can get jostled or moved to a different location, which impacts the strength greatly. let's skip to the next slide, Nino. So field cured cylinders is probably the more difficult one to actually achieve correctly. ASTM says that if you are field curing, you're doing this to determine if the structure can be put into service. You're going to compare them to standard cured cylinders, but know that there's going to be a difference naturally. And so this is going to be like we're opening up a roadway, we're stressing a deck, and we need X PSI to do that. ASTM states that we are to cure these cylinders in as close to the same condition that the structure is being cured, and secondly, as close to the area we tested as possible. Meaning if we're doing a 200-yard deck and you tested the 100 cubic yard truck, we'll say, wherever that 100 cubic yards fell on that deck is where those field cured cylinders should be sitting and then covered or cured in the same manner as the entire deck. This is rarely achievable, and what we commonly see is what you see in this picture, where a whole jostle of cylinders meant for field cure are together somewhere and usually far away from where the concrete's actually at. If we know, what we know about concrete is that as it hydrates, it generates heat. Heat is what gives us our strength. So when we're looking at field cured cylinders and we're looking at early strength, and you remove this 4x8 cylinder from the mass heat of the slab, your field cure is always going to come up low. And on vice versa, if we put this field cured cylinder in a heated environment, a water tank that's heated, insulated box, and we don't protect the slab in the same manner, we can get ourselves into some trouble here when we break that cylinder and see that say it's at 3,500 PSI, and we get the green light to stress the deck, but the deck froze and the field cures didn't represent that. And now we may have a blowout or other things that can happen. Next slide, Nina. Transporting is just as important as making and curing the cylinders properly. You can have the all-star team make the cylinders, but if someone who picks them up doesn't care for them properly, you can do a lot of harm. ASTM says that you need to wait 8 hours after final set. Industry standard is that it's typically the next day, but you are required to do this within 48 hours of that final set time. While you're transporting it, you should protect it with suitable cushioning material to prevent jarring or any jostling around of that cylinder. They're still in a very fragile state after one day, and they can microfracture. Transport them in the upright position, protect them from loss of moisture. Typically this is done with just what you see there with the cap, a watertight lid. And then during the hot weather, you should protect from direct sunlight, high temperatures, rapid evaporation. ASTM recommends you submerge them in water while you transport them. This is very rarely seen. And during cold weather, you protect them from freezing. Next slide, please. Once they get back to the lab, requirements get a little bit tighter. And within a half hour of them arriving, you're to strip them and cure them with free water on the surface at all times. What we have pictured here is a field lab. This is an absolutely acceptable way to cure these cylinders. Commonly, testing agencies, ready mix suppliers will have 100% humidity room or a fog room where moisture is getting applied to the total cylinder surface at all times. But the temperature requirements tighten up a little bit, where it's 73.5 degrees Fahrenheit plus or minus 3.5 degrees. Next slide, please. So this is a video of the actual compression of a cylinder. It's actually a great video. So you see a great explosion. Now what we can't see here is that typically the bottom is what's moving. It's slowly rising up. This is where the 1/4 inch per foot levelness becomes important, because as you bring these to the lab, you're measuring them with calipers to the nearest 100th of an inch. And you're using this measurement to determine the surface area of the top of that cylinder, which the load is being applied. Pad caps have become very common, but ASTM C39 recognizes that if we are using a removable cap, you can see a type 5 or 6 fracture, which is when just a corner chips off, either on one end or both ends, being it's type 6. can happen before ultimate capacity is achieved. And what ASTM recommends is that the technician continues to load that cylinder to verify that that cylinder has achieved ultimate capacity. This gets overlooked, I think, because so many cylinders are sitting there to test. It's hard to give the extra attention to one. So one thing I would advise to look for are a number of type 5 or 6 fractures on your report, as ASTM, like I stated, does recommend that ultimate capacity may not have been obtained. Next slide, please. So here it's listed as problems and solutions. It's more of a problem and result. Typically, when we're looking into a low strength investigation, it's not just one item that did this. It's typically a cocktail of several items. It could be that they were in a too hot of an initial environment when they were initially cured, and you can see on the right that alone can bring a 15 to 50% strength loss. Maybe they were too cold or they froze. You can see even higher, 50 to 75% strength loss. Something interesting about when they're cold or frozen is the water is actually, it can leave a crystal impression in the concrete. Always a dead giveaway that obviously the concrete had frozen. If the cylinders are moved during the initial cure, this is a wide range and for a good reason. So 2 to 20%, and this is because if you move them, ASTM says move them within 15 minutes to their initial cure location. If you move them, say at 20, right, that concrete has started to gel up, but not nearly as much as if what you can commonly see is on a large pour, I'll make all of my cylinders and leave them at the table, and then at the end of the day, I'm going to move them all. And now the concrete has really started to gel, crystals are starting to grow, and we're moving it and we're fracturing, we're microfracturing these cylinders, and that's when you can kind of get more into that 20% range. Improper transport, another wide range, because this could be anything from just a little jarring to what we saw in the image where they were kind of tossed in the back of the truck just to let traffic do its thing. Cylinders left in the field more than 48 hours. The NRMCA does recognize this as being a heavy hitter in strength loss, and we see it commonly on Thursday and Friday placements where they get picked up on Monday, or if there's a holiday in that time. But you see the strength right there. Reuse of plastic molds. This used to be common. It's really not so common anymore, but that can bring up to a 22% strength loss. The end's not flat. This is where we were talking about. You're probably going to see a type 5 or 6 fracture between 30 and 75%. And if we're not using in-spec neoprene caps, or if we're sulfur capping but allowing for some void space, or it's too thick, etc., that can bring a 10 to 30% strength loss. All of this stuff boils down to potential job delays. Sometimes we can Swiss hammer to verify strength. Sometimes we can use a Windsor probe, but typically those are just estimates of strength, and we usually move to coring, which is a destructive test. We try to avoid that at all costs. And I believe next speaker will be Jason.
Thanks, Don. Try to make this brief here real quick, but this is pretty important information here, I believe, especially for those of us who've been lucky enough to live in Colorado with the extreme weather we get here and the issues we've seen with placement of concrete in these extreme weather conditions. So since we're coming out of the hot weather, we'll kind of dab into that a little bit first here. But hot weather concreting is any combination that may impair the quality of the fresh concrete. So whether it be high ambient temperature, low humidity, high wind speed, high concrete temp, or solar radiation. ACI 301 and 305 actually state a limit of 95 degrees on the concrete, but most specs you'll see will be 90 degrees max. Colorado Springs and CDOT for sure. You have different ways of getting around dealing with the hot weather. the adverse effects it'll have on the concrete with the use of hydration stabilizers, which come in handy with the hot weather. And a big issue with hot weather concreting is your plastic shrinkage cracking. Cold weather concreting, as we know, can't stop construction when winter starts. So you do have to take precautions though. Cold weather concreting is if your ambient air temperature is 40 degrees or lower, or if there's 50 degrees, I'm sorry, I lost my note here. Well, cold weather concreting, 40-degree temperature. You want to protect against your early freezing. It can cause delayed set times. Frozen subgrade seems to be an issue. You don't want to pour on that. Cold formwork, that'll delay your setting time as well. And then you get the over finishing or early finishing, which can create your plastic shrinkage cracks and other surface defects, such as crazing. Next slide, please. So here, this picture on the right is a perfect example. This picture was taken maybe a month and a half ago on a very hot, windy day. And this concrete is about 2 hours old and kind of hard to see, but you can see the cracks forming in the surface of the concrete. And that's caused by the rapid evaporation loss on the surface, which causes your volume change on the surface and the cracking. But again, things you want to be ready and prepared for in hot weather is your accelerated set times, the increased rapid evaporation of the surface moisture, which causes those cracks, increased water demand to obtain your desired slump. And with that, if you have to add more and more water, you're looking at lower strength, increased permeability due to the cracking, and your increased potential for plastic drying and shrinkage cracking. Best way to prevent the shrinkage cracking, which seems to be, in my experience, one of the biggest issues with hot weather, is the use of con film or something to keep that surface moisture there while the concrete is setting and the bleeding is taking place. Next slide, please. Cold weather, we all know we place in it. It's not necessarily fun, but we got to take the proper precautions in order to make sure that the concrete that's put in place doesn't freeze. Especially if it's a structural member and it's going to be load bearing. You don't want that to freeze and potentially cause a failure down the road. You never want to place on snow or frozen subgrade. That'll cause your concrete to freeze and never really meet ultimate strength. Concrete setting times, they double approximately for every 20-degree drop in concrete temp. Concrete must meet a minimum temperature depending on air temp and dimension of the structure. And you can find a table in ACI 306 that spells out however big and thick your member is, whether it's a footing or sidewalk, depending on the thickness, what your minimum temperature should be for your concrete. Concrete that will be exposed to freeze-thaw cycles over its life must be air entrained. I know there are times when pouring a garage, the garage slab, and then we've got 3 or 4 yards left over. Well, let's just throw that in the driveway. That's not a good idea. You're going to have an extensive freeze-thaw damage from that on that portion of that driveway if you don't have the air entrainment in there to allow for the expansion of that water that freezes within the concrete. Concrete should be protected using curing blankets or whatever manner is suitable for the structure that you're pouring until, you should maintain the moisture and the temperature until the concrete reaches 500 PSI and should be protected from freezing until then. Anything that's going to be saturated with water should not be exposed to freeze-thaw cycles until reaching 3,500 PSI. You want to make sure you've got that strength in there, so that way it doesn't start to freeze, crack, and lose your strength. And then rapid exposure to the cold temperature should be avoided at early ages. You don't want to have a curb and gutter that you've got cured and it's underneath the blanket, you're sitting at 75 degrees and outside it's 15, and you take that off, you'll have some thermal cracking, that potential that could happen there and completely ruin that. Next slide, please. And then jointing. Jointing's another big thing. Not only the timing, but the type. Your isolation joints, which is just going to basically separate anything, a slab that you're pouring, say up against the foundation of a house, whether, you know, be a patio. You want to put in those isolation joints that separates the new concrete from the old structure to allow for the horizontal and vertical movement of that slab as it changes volume as it cures. Should it extend the entire depth of the slab so you don't have any part of that slab trying to adhere to the old one and creating cracks. Your contraction joints, these ones are extremely important. This is kind of more or less just a pre-planned crack. You know concrete's going to crack. It's guaranteed to do two things: get hard and crack. We want to try to tell it where to crack. So with these contraction joints, you can either tool them or you can saw them. And the timing of each, the tooling is typically when it's still plastic and in the placing operations. Sawing happens after initial set or hopefully a little before initial set, but there's timelines set out depending on what kind of saw you're using. And then another good thing, or another thing that you want to be aware of, is your spacing and your depth. You don't want your joints to be too far apart, because then it's going to find a weak point between those joints and crack there. You want to have them no more than 24 to 36 times the slab of the thickness spacing, and you want it at least a quarter of the depth deep in order to create that weak plane for it to crack. And then construction joints, full depth joints placed in the slab where the concrete operations have completed for the day. So say you've got you've got some paving you're doing, you get down to the end of the day, but you know you're going to be placing right up against that again. You use your dowels or however you create your construction joint. And another good place for this is if you have delays in placement due to truck delays. You don't want a cold joint, so you'll create a construction joint at that spot and hopefully be able to start placement elsewhere, or maybe have to continue the next day. Next slide. I believe this is where Matt takes over.
Can you hear me?
Yes, we can hear you, Matt.
Okay. Let's go to the next slide then, please. And my broadcast seems to be a little bit behind, so just let me know when you're on the slide 54.
We are on that slide currently that has maintenance surface moisture with the picture,
Okay.
the couple of pictures.
Thank you. Yes, so just mentioned the fact that you want to be proactive and not allow the concrete surface to dry out. It's sunny here, it's arid almost all the time, very breezy, and the weather can change quickly. It can get hot in a hurry and it can get cold in a hurry, right? So you're dealing with a lot of temperature variables, but the one thing that's constant is it's an environment where moisture is going to evaporate, right? So that's why everybody has swamp coolers. Your concrete surface is going to end up being, especially for flat work, that's your wearing surface. And you need it to be durable and strong and as impermeable as possible. So you do not want to allow it to dry out, because all concrete needs water in order to hydrate. And as you're finishing, if your bleed water completely evaporates off and then your surface begins to dry, hydration stops. And then it's going to be very difficult to resume any type of finishing that you hadn't completed, right? So there are a couple things you can use in order to stay ahead of this. There are evaporative reducers and there are finishing aids, and there's definitely a big difference between the two. So we're going to talk a little bit about that, but both of them can help you to some extent avoid or minimize plastic shrinkage cracks. It can eliminate the need to bless concrete with water, which is kind of like an age-old term that's used when people just throw water across the surface in order to get a little paste worked up so that they have something to finish. And then, of course, the goal here is to avoid any premature surface deterioration. Let's go to the next slide, please.
I'm on the next slide.
Thank you. All right, so let's talk about evaporative reducers. So they work by forming a monomolecular film on the surface. I kind of look at it like you just put a piece of saran wrap across the surface of the concrete that's slowly going to evaporate away. And you just have to keep an eye on the way the surface looks to tell when it's time to reapply. But your goal is, in between finishing passes, you put a layer of your evaporative reducer on the surface, and it prevents any or minimizes to a great extent any evaporation of the moisture. And so as it wears off, hopefully you got it timed right, it's time for your next finishing pass, and you've got a good surface to work with, and it's not dried out, and it's easy to close up and do your thing. So there's a few names, about just general names like Confilm, Monofilm, Eucobar. They're all about the same thing. We talked about some of the pros, but let me talk about some of the cons with this particular product. It does wear off quickly, right? But the big problem is the misconceptions on what it is and how it should be used, because if you follow the mixing instructions, it's 90% water, 10% active ingredient, I suppose. And if you put it on the surface and then you work it in with any of your tools, you're changing the water cement ratio of the surface of the concrete, which is you're going to increase the water cement ratio, has an inverse effect on strength. So your strength goes down. Your durability ultimately is going to go down. Your permeability goes up. It just makes the surface a lot weaker than anything that may be a quarter inch below it, for instance. Let's go to the next slide, please. Because we'll talk a little bit about finishing aids, and they've come a long way with these. I've got an example here of a couple. Day One is the one I'm most familiar with. There's others. Slabus Discme is one name, right? But what these are, they are designed specifically to be worked in. And the more you use and work into the surface, the more you can positively improve the concrete properties. So Day One, for instance, is a nano silica product that will actually work its way into the crystalline growth areas of your cement that's hydrating, right? And it'll create more calcium silicate hydrate. So you're creating more density, more strength, less permeability, right? So you can use it almost like it's an evaporative reducer and it's safe to work in, or you can use it in greater concentration and actually use it as a performance improver. The cons on this particular product, it definitely is expensive. There might be a little bit of sticker shock, but there's also something you have to consider is that, you're going to get something out of using this. This is going to either give you some good insurance to avoid early deterioration, or it might be something you can leverage to actually improve the performance of whatever concrete you generally use, right? So you just have to weigh the pros and cons for whatever type of work you're trying to do. But if it's exterior paving in Colorado, I think it's a sure bet winner, and there's definitely no downside to using it and finishing it in. But if you finish Confilm in, that will do some damage. And that's all I have on these two topics.
All right. Thanks, Matt. So if you need to find the approved concrete mix designs, those are available at CDOT, and the link is available shown on this presentation, as well as ones for the city of Colorado Springs. The guys from CRMCA, Action Ready Mix, Pete Lean, Transit Mix, and Martin Marietta have volunteered to provide plant tours. So if you guys would like to do a plant tour, you can see JT's email address there. Shoot him an email and let him know, and he'll arrange some times to do some plant tours. And if you enjoyed those videos are available on YouTube if you want to rewatch them one more time.
Thank you, Tyra. So with that, we are going to go to questions, and I am going to put my phone number in. That way anybody that has questions can text them to me. We do have one question that I've received, so I'll read that after I've got my phone number listed.
And Nina, while we're taking additional questions, again, I did want to highlight that we have 2 upcoming EPC Engage events. The one coming up in November for kind of the how-to for realtors. That is Realtor's Guide to Planning and Zoning. And then the other one will be in January, and that'll be focusing on financial assurances associated with development. Really want to thank all of our presenters today as we take questions. I also did want to highlight that I got information from our 2 inspection supervisors, our inspection supervisor Rick Ryder at Public Works, as well as Brad Walters in our department, Planning Community Development, stating that I think there was a comment made earlier about trucks that have high slump and ways to adjust that. But we at the county do not accept trucks that have a high slump. Those will be rejected. So it's important that we just clarified that for the purposes of this presentation. Any questions we have, Nina, that we can ask the panel to address? And I will say we are out of time officially, but I would like to take maybe 3 or 4 questions if there's some out there.
So I haven't received any new questions. You just provided information on that email that we had received. There was one question that was entered into the comments. How thick is the concrete sidewalk for a commercial driveway? Or sorry, commercial development. So how thick is the concrete sidewalk for commercial development?
I think Brad is officially gone. I'm pretty sure I know the answer to that. I think it's 6 inches, if I remember correctly, maybe 5. Maybe someone else can correct me if I'm wrong on that.
Greg, for the city, if you are crossing a driveway, it has to be 8 inches. Otherwise, it can be 4 to 6, depending on what the usage is.
Thank you. I knew you'd correct me, Tyra. I appreciate that.
I do have an additional question. What is crazing?
Crazy. What is that in reference to?
Joe, why don't you answer that one?
It's what happens when you're in this business long enough.
Any other questions? Nina, is your phone ringing off the hook yet?
I got another one.
Okay.
What do you?
I could actually
touch base on crazing
answer the crazing question. Yeah.
Okay.
Go ahead, Don.
Okay. Crazing or map cracking, you'll see it's a surface defect. It's not structural, but it looks like a road map, right? It's just sporadic, chaotic, little cells network of cracks. It's commonly caused by if you poured too wet, if you inadequately cured the concrete. Environmental conditions can help this, like high evaporation rates. But that's essentially it. It is a cosmetic issue. I actually like how it looks, but not that, that maybe would be my countertop and not my warehouse floor. But it's caused when you finish the concrete, when there's bleed water still on the surface. You're weakening that initial water to cementitious ratio. You're increasing, so you're weakening that surface concrete, and it's causing it to microfracture almost.
Great
So the
question.
next
Thank you.
question. Sorry, Craig. The next question is, what do you look for when testing from a pump truck?
I can answer this one as well.
I would look. Yeah,
go ahead.
I got to grab this one. Another one near and dear to my heart. Honestly, we get caught up a lot of times between wanting to test at the point of placement to verify the properties of the concrete as it's entering whatever our formwork. Whereas a ready mix supplier is going to want to have the concrete tested as we delivered it, because we have little control over what may happen to those properties once they go through the pump. So what we're looking for is if you're going to test out of the end of the pump, is to make sure we're doing it, according to C172. So there's a continuous stream. In other words, don't stop the pump, move it, have somebody stand there with a bucket, take one stroke, try to capture the concrete as it comes out, and then base your test off of that. That's not a good or representative sample. So that's briefly what I would look for.
Right, that and the prime has completely been discharged from the pump is vital.
Yes, and one other comment I have towards that is that there's a lot of what they call slick packs that are used, which he said is pump prime. That should all be discharged before anybody gets a sample of their test. And one of the things we specify, because of the latest research that has come out from the University of Oklahoma, is that the air can be affected by the pump pressures. There's too much science to go into it here. So based on that information, what we do is air acceptance is at the back of the truck and slump acceptance is at the end of the hose, because slump can be affected by the pumps as well.
Hey, Joe, I wanted to add one more thing on that. You really need to be cautious when testing at the end of the hose of a pump, and you really need to take a safety moment there, because there are some pretty sketchy situations if you choose to test at that location.
I agree. Also, I should mention that out in the field, one of the things we've been seeing lately is a lot of uncertified testers. So ACI requires that they be Field 1 certified, which they can get through the Colorado Ready Mix Concrete Association. However, we understand that there's a lack of available workers, and so people are hiring them and they're trying to get them trained. That's fine. However, their supervisor should be on site until that person has the test down to where they are almost performing it perfectly. So that supervisor should be there to supervise them to make sure that they're doing their job correctly. Because too often we see what they're doing is they're not taking the sample in accordance with ASTM C172. They're not rodding the test, whether it's a slump or the air pot, the correct amount of times. They are not performing in the test on a flat level surface. And it's all those can have a significant impact. And unfortunately, the joke is that the lowest paid person on the job can have a negative effect on the most expensive product on the job, which is a 10-yard load of concrete. You're looking at a minimum of $1,500 to $2,000 being lost if the tester doesn't do his job correctly. And so we are very concerned and adamant that they do their jobs correctly for that reason. And that's why we've all taken the time to be here today. And so I think one thing we also should mention is that ASTM C94 Section 17, if I remember with the latest update, allows for a retest. So if a slump shows up and it's a 6-inch slump, we are allowed to have a retest performed before that truck is rejected. And that retest can be, how do we get that slump down? Often it can just be because the test wasn't done correctly, or the testing, the test was done on an improper surface, or the tester just didn't do the job right. So what we've done, and sad to say, as ready mix producers, a lot of us have taken the necessary actions of videotaping with our cell phones, and it's really amazing how sometimes a 6-inch slump can go down to a 4-inch slump in 10 minutes when that tester is being videotaped. So the point is, we just ask that they do the job correctly, because it can have a huge financial impact on us.
So I think since we're almost over, I'm just going to take one more question so that everybody can continue on with their days. So the last question is, for testing for air, is it best practice to hit once with a mallet or multiple taps to get the final measurements? I see both with different results.
Well, if no one wants to interject on this, I'll say you're supposed to smack it once smartly. Now that definition of smartly can vary for everybody, but technically you're supposed to hit it one time. And then after they do that, they're supposed to take a reading. They should lightly tap their gauge. If they start getting a little carried away, you can cause the apparatus to leak because you could be jarring it. So technically one time.
Okay, well, I think that's our last question. Again, to our panelists, amazing job, great information. I really appreciate the participation and the technical knowledge, just very impressive. So much information here. There's additional questions after this. Please feel free to reach out to either the city or the county. I think we either one of us can find the appropriate answer for you. And with that, we will bring this to a conclusion. Hope everybody has a wonderful rest of your week, and we'll see you next time.